Assalamu alaikum. I am Umar and now we are discussing about the second part of mass spectrometry. The fifth part of mass spectrometry. After the ion have passed the exit slit, they collide on a collector electrode. The resulting current is amplified and registered as a function of the magnetic field force or the accelerating voltage. We can also change the radius of the electron. The applicability of mass spectrometry to the identification of compound comes from the fact that other interaction of electron with a given molecule and excess of energy result in the formation of wide range of positive ions. The resulting mass distribution is characteristic fingerprint for that given molecule. Here are certain parallel with IR and NMR. Mass spectrogram in some ways are easier to interpret because information is presented in terms of mass of structure component. There are two fields. There is magnetic field and there is field electric field. We can change the radius of the electron by these fields. Sampling, as already indicated, a compound normally is supplied to a mass spectrometry as a vapor from a receiver in the receiver. The prevailing pressure is about 10 to 20 times as high as in the ionization chamber. In this way, a regular flow of vapor molecule from the reservoir into the mass spectrometer is achieved. For fluid that boils below about 150 degrees centigrade, the necessary amount of evaporate at room temperature. For less volatile compound, if they are thermally stable, the reservoir or can be heated. If in this way sampling cannot be achieved, one passes on to the direction insertion of the sample. We have to lower the pressure because it is very important. If we have to know yeah, we will know the note the pressure. We will cannot get the electron mass. The quality of the sample, volatile and needed amount are about the same for mass spectrometry and capillary gas chromatography. Therefore, the effluent of GC often can be brought directly into ionization chamber using the made of the excellent separating power of GC combination with the power of identify of the mass spectrometer. When packed GC is used with a much higher supply of carrier gas, it is necessary to separate the carrier gas prior to the introduction in the mass spectrometer jet separator. The ion source, the scheme of an ionization chamber. Ion source, typically electron impact, is represented in this chamber in several ways. Ion of the compound to be investigated can be produced. The amount of most common way is to bombard vapor molecule of the sample with electron of about 70 eV. These electron are generated by heating a metal wire filament commonly used by tungsten or rhenium. A voltage of about 70 volt from 5 to 100 accelerate these are returned towards the node. And we know that the tungsten symbol in the periodic table is W. After that, during the bombardment of one or more electron can be removed from the neutral molecule, thus producing positively charged molecular radical ion. Only about 1 in 10 power of 3 of the molecule present in the source of ionized. The ionization probability differs among substances, but it is found that the cross section for most molecules is a maximum for electron energies from approximately 550 to 100 eV. Most existing compilation of electron impact spectra are based on spectra recorded with approximately 70 eV electron. Since sensitivity is here close to maximum, fragmentation is unaffected by small changes in electron energy around this value. During this ionization, the radical ion on average gain an excess energy enough to break one or more bound on NS fragment ions. After that, a possible fragment of the molecule A, B, C, D is presented. It should be stated here that this is a simplified presentation and that in real life a multitude of possible ways to form fragments. Even if via rearrangement reaction exists, its fragmentation of a molecule radical cation to give a neutral molecule of a new fragment radical cation is also possible.